get started on this here. So looking at the first page, problems 1 through 6, are there any questions on problems 1 through 6, or any of those that y'all want to see how they are done or worked? Is there any questions on naming the circle, naming two radii or radiuses, or two radii, naming two chords, the diameter, or naming a secant line? Any questions on 1 through 6? We're good with 1 through 6. The one thing you need to make sure to pay attention to, and I will mark it wrong, is if you say name the secant line. So a secant line for this here, so a line that crosses at 2 points. So e.g., if you write this here e.g., this is not a secant line. What is this? It's a chord. It would be a segment because it connects 2 points on the circle. So as soon as you draw the two arrows, making sure it's a line, it is a secant line. Because if it asks for a line, you need to have the symbols for the line. Otherwise, it will be marked wrong. The same thing for tangent line and kind of those there. If it asks for a line, you need to give a line. On the quiz, I gave it to you, especially if it wasn't an actual chord. So if you had 2 points that were off the circle. So if there was another point up here and you did H and whatever that point was, I gave it to you on the quiz. On the test, you're going to have to actually make sure you have the line. So any questions on any of these here for 1 through 6? Questions on 7 or 8, externally or internally tangent? It's considered externally tangent if the tangent line does not do what? Cross the line, the imaginary line that connects the two centers of the circles. So for this here, number 7 would be internally, because if we connected the two centers here, that tangent line does cross it. It crosses between them, so it would be internally tangent. For number 8, it does not cross that imaginary line between the two centers, which would just be from here to here, so it would be considered externally tangent. So any other questions on 7 or 8? 9 through 11, tell whether AB is tangent to the circle. Well, for us to be able to use this here, we're using the Pythagorean Theorem, a squared plus b squared equals c squared. Because if it is tangent, then it will make a right angle. And as we have it set up here, it would make a right triangle. So is there any one of these 3 here that y'all want to look at or see how it's done specifically? So we can look at, let's just pick number 10. Now number 10, even though it goes through the whole circle, it talks about the diameter, it still works just fine. It's just also that the other side of the line, because 16 is only the radius, we need the whole length, which would be 32. So if we plug this in, it would be 32 squared plus 63 squared is equal to 65 squared. And really at this point here, we can type this into the calculator. 32 squared plus 63 squared would be 4,993. 65 squared is going to be 4,225. Well, those are not the same, so is it tangent? Well, no. And that's all we have to do for this here, because if the Pythagorean theorem holds true, then it is a right, then it makes it a right triangle, which means that line is tangent to the circle. Any questions on this here? Are we good with 9 through 11? Okay. Questions on 12 through 15, or 12 and 13 in particular? Do we want to look at 12 or 13? So 12 through 15, all four of these are the exact same. I'll just pick 14. Because if we do have two tangent lines that meet outside the circle, the distance for these two lines are going to be the same. So if we were to solve for x, we would just need to set these equal to each other and then solve for the value of x. Now at this point here, what we're going to do is we'll add 15 to both sides. And we can add these two together. 4, carry the 1. We would get this here. And then the next thing we would do is divide both sides by 6. Tells me x squared is equal to 24. 54 is 9. So Leah, make sure to watch this, go back and watch it so you're ready for tomorrow. And then last but not least, we need to square root both sides, which tells us x is equal to plus or minus 7. I want you to at least get the 7. If you get the negative 7, even better, because it is the positive and negative case. So any questions on this here, or how we got to this point? Are there any other questions on 11 or 12, 13, 14, or 15? Because all four of these here are the exact same. We set the two lengths equal to each other and then solve for the value of x. So we're good with this here? Okay. Questions on 16 through 21. 16 through 21. Or any one of these in particular y'all want to look at? Now with these here, a central angle measure is the same as its arc. And we can add those together or subtract them. But we do know that the entire circle is 360. So we can use those properties to find these measures. So EA, if I wanted to find this, well, we could add all the others together and subtract it from 360. And if we added all the other ones together, we would actually get that it is 270. And if we subtract 270 from 360, we should get 90 degrees. So EA is 90 degrees. Now, is that going to be a major, minor, or a semicircle? It's going to be a minor arc. Minor arc is less than 180. Major arc is greater than 180. And a semicircle is exactly equal to 180. And I don't think any one of these here on the review sheet actually equals 180 because there's no combinations of these that will actually add together to be exactly, let me see here, exactly 180. It doesn't quite work out for this here. But if it does equal 180, then it is a semicircle. So for most of these here, so be paying attention that you put what the actual measures are and describe it as major, minor, or a semicircle. Because I have in years past and on the quiz, either I just got the measure, so like 90, or I just got minor. Because if you don't include both, you will not get full points. Because you will get counted off if you don't have both, if it's asking for both. Questions on this here? 20? EDB. EDB. So if we add these three together, because, well, if I can write, 39, 51, and 40. 9 and 1 is 0. Carry the 1. 4, 5, 6, 7, 8. 8 and 15 is 130. So EDB would be 130, and it would be minor. Does that disagree with the back? What does it say on the back? 140. Yep, so the back is wrong. It should be 130. 60, 70, 80, 90, yep. Yeah, if it was 61, then that would work. But, yeah, past me got that wrong. He carried a 1 when he shouldn't have. ABD. 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 So 140 and 40 would be 180 plus our 39. 9, 1, carry the 1. So it should be 219, and this would be a major arc. Because I think that one is right on the back. But I don't have it in front of me to check. Any other questions on these here? Are we good with the minor, major, determining the arcs, adding them together, subtracting them? Questions on 22 or 23? Is there a question on 22 or 23? Actually, let's not even worry about it. They're not on the test. Yeah, because there's some parts of this that we're not going to worry too much about. Like these aren't going to be there. Nope. All right. So let's look at 28 and 29. Any questions on 28 or 29, or one of those that y'all want to look at? '28. Well, since the diameter intersects the chord at a right angle, it means it is a perpendicular bisector. So the value of x is what? And the value of y is? Because if the diameter intersects a chord at a right angle, it actually cuts that chord in half, and it's 2 arcs. Yes. So we look at this here, as we just said, same setup. So 4x minus 36 is going to be the same as 2x plus 24 because those two sections of the chord are congruent to each other. If the diameter intersects a chord at a right angle, it bisects it. So at this point here, we just need to solve for the value of x. We can add 36 to both sides, which will tell us that 4x is equal to 2x plus 60. Which will tell us that 2x is equal to divide by 2, which tells us x is equal to. And again, so this is just using the properties of chords to find this here. Now we also need to find the value of y. Well, y minus 5 is equal to 40. Because again, those two arcs are going to be congruent to each other. And the real key thing to look out for this here is that one of these two chords is the diameter of the circle. One of them's the diameter and the other is a chord, and they intersect at a right angle. That is what's key for this here. Any questions on this here? All right, we'll come back to these later. I want to make sure we get to everything else first, and then we'll come back to that one there. Questions on 32 through 35, any one of those in particular before I just pick one out at random? Okay, 32. It's wanting us to find the measure of angle D. We want to find this angle here. Yes. ABC is what kind of angle? It's an inscribed angle. It's inscribed on the circle. Any inscribed angle where the vertex is on the circle is half the measure of its arc. So since the arc is 164 degrees, we divide that by 2, which is 82, or we're essentially taking 164, dividing it by 2, and getting 82 degrees. The inscribed angle is equal to half the measure of its arc. It can also go the other way around. The arc is equal to twice the measure of the inscribed angle. So on 33, we're told that the inscribed angle is 37 degrees. So we can multiply 37 by 2, which gives us 74 degrees. And we can find the measure of AD. Any questions on this here? Now, what would be the measure of ADC for this here? Well, it'd be 180, because what is AC? The diameter. So any arc that connects to the two ends of the diameter is automatically 180. It's understood to be 180 degrees. Any questions on either one of these here? 36 and 39, we have these inscribed, well, 36, 37, 38, or 39. Are there one of those four that we want to look at? Because it looks like I don't have 35 or 30, 34, 35 in there. Questions on these two here or one of the others with the polygons? So I'll just pick one of these here. Let's just look at 37. Well, whenever we have an inscribed polygon inside of a circle, the opposite angles add up to be 180. So 3y plus 102 is equal to 180. 4x plus 74 is equal to 180. And once we have these set up, all we need to do is solve for the value of x. So for y, we can subtract 102 from both sides, which tells us that 3y is equal to 78. Now at this point here, we can divide both sides by 3, telling me y is equal to 6, 18, 26. Any questions on how we found the value of y? Now we can do the same thing for the value of x. First thing we would do is subtract 74 from both sides, which tells us that 4x is equal to 106. Divide both sides by 4. And that's it. That's all we have to do for these here. Any questions on 36 or 37? We ready for the next? In a triangle, the inscribed angle is always going to be what? Not 180, but it's half the measure of the arc. And the right angle, or this angle here, 4x, is attached to the diameter, yes? So its arc is 180. An inscribed angle is equal to half the measure of the arc, so it would have to be 90. So the angle, the inscribed angle on a triangle whose one side is the diameter, one of them is going to be 90. So for this here, 4x would equal 90. We can divide both sides by 4 and see that we have 2, because that'd be 8. I believe it should be 22.5. And because of our acute angle theorem in right triangles, since one of the angles of a triangle is 90, and they all have to add together to be 180, the other two acute angles have to add together to be 90. And we can use this here to solve for the value of x, or value of y. So at this point here, we can subtract 42 from both sides, which tells me that 2y is equal to 48. Divide both sides by 2. And we get that y is equal to 24. Any questions on 36 through 39? Any questions on anything we've done so far? Hopefully not moving too fast at this point. Questions on 40 or 41? So 41. Angle 1 is 49 degrees. Its arc, AB, is going to be twice that measure. This is still talking about inscribed angles. So since angle 1 is 49 degrees, arc AB would be twice it, so we multiply 49 by 2. So AB would be 98. Now we know the entire circle is 360 degrees. So to find BCA or ACB, we can take 360 and subtract 98 from it. 2, 6. Nope, that's not right. It is 262. Yep. Well, that leaves us with just one more thing, the measure of angle 2. Yes? Well, the way that we got AB was because angle 1, the arc AB is twice the measure of angle 1. So the measure of angle 1 is half the measure of its arc. The same thing is true the other way around. BCA, ACB is equal to twice the measure of angle 2, or angle 2 is equal to half the measure of its arc. Since the arc is 262, we're going to do what? Take 262 and divided by 2, which gives us 131. Well, what's angle 1 plus angle 2 equal? So angle 1 and angle 2? Because the arcs would add together be 360. 49 and 131 is? What's the measure of a straight line? So it holds true. Any other questions on 40 or 41? So AD is 75. So if I wanted to find ACD, well, we would take 360 and subtract 75 from it. 8. And I think we should get 285. 360 minus 75. So we get these here. Now again, if we're going from the arc to the angle, we take that number and divide it by 2. So we can do 75 divided by 2, which should be 37.5. And that'd be for the measure of angle 2. Then we can take 285 and divide it by 2, 140. And well, 37.5 and 142.5 still add together to be 180, the measure of a straight line. Questions on this here? On the answer key? Oh, there. Yeah, that 4 looks a little weird. Any other questions on this here? Questions on 42 through 47, one of these in particular. 43. So, when we have two chords that intersect inside the circle, the measure, so y, is equal to 1/2 the sum of the two arcs, which would be 73 and 111. And we're always looking at it being kind of in a straight line. Y, arc, arc. They're always going to be kind of in that uniformed form. Now at this point here, we can just go on and calculate this out. So we have 1/2. We can add these two together and get 184. And 1/2 of 184 is 92. Those two added together, divided by 2 or multiplied by 1/2. 184 times 1/2 is going to be 92. Any questions on how we found the value of y? Now, we know that x and y make a straight what? Line. What's the measure of a straight line? So 92 and x add together to be. So I can take 180 and subtract 92 from it. 88, so x is equal to 88 degrees. Any questions on this here? Huh? Yes, we can look at 42. Now, when the two secants intersect outside the circle, the exterior measure is going to equal 1/2 of the bigger minus the smaller. Now, when there's more than one term, you need to make sure that that subtraction sign is applied to both. So for us here, the negative sign is going to be applied not only to the x, but also to the 6. So really what we have here is 34 is equal to 1/2 of 3x minus 2 minus x minus 6. Now we can go on and combine like terms. 3x minus x is 2x. Negative 2 minus 6 is negative 8. Now, when we covered this in the lesson, we went on and multiplied both sides by 2. Now here, is 2x and 8, are they both divisible by 2? Yeah. The reason we multiplied both sides by 2 was because all the problems we came across, all the things that were left over inside were not even. We had some odd numbers. So to avoid decimals, we multiplied both sides by 2, and that works. Here, if I multiplied this by 1/2, we get 34 is equal to, well, 2x divided by 2 is x. 8 divided by 2 would be negative 4. We're essentially dividing each thing by 2. Or 2 times 1/2 would be 2 over 2, which is 1. 8 times 1/2 would be 8 halves. 8 divided by 2 is 4. Now, if these are odd, go on and multiply by 2 and solve. Here it worked out nicely that they're both even, so I can divide them by 2 and simplify. Add 4 to both sides. And we get x is equal to 38. Questions on this here? Are we good with this here? Questions on 44 or 45? 44 or 45? Is there one of these that we want to look at? So these here still follow along the same principle, even though that they are tangent and a tangent and a secant line. The principle still hold true to the one that we just did. The exterior angle is equal to half the measure of the bigger minus the smaller. So if there's not one of these two we want to look at, we can go on and move on. Any questions on 46 or 47? What's the measure of angle x? Because x and 45 degrees are vertical angles. Vertical angles are always congruent. Yes? It works out that we could have set this up as y is equal to negative x plus, or 1/2 of negative x plus 30 plus 7x plus 42, defined and use it that way, but we didn't need to. Because of the 45 on the inside, it actually gave us x and y. Any questions on 47? What's the measure of angle y, or arc y? It is. If the arc is the same, the arc measures the same as its central angle. Now, because we do have two tangent lines and a central angle, the measure of the exterior is equal to 180 minus the central angle. So 180 minus 120 would be 60. Because we also have a four-sided figure, and all four angles add up to be 360. Well, I know two of them are 90, and one of them is 120. So we could have added them together. So 180 plus 120 would be 300. 360 minus 300 is 60. So we could have done it in either fashion. Any questions on 46 or 47? Are we good with 46 and 47? Questions on 48 through 55, or these two here, 48 or 49? Questions on 48 or 49? Let's look at 48. When we have two chord measures, the chords each other are equal to the parts multiplied together. So 6 times x minus 1 is an equal 4 times x plus 3. The two parts of the chords multiplied together will equal each other. So one part of the chord is 6, the other is x minus 1. For the other chord, we have 4 and x plus 3. And at this point here, we just need to solve for the value of x. So we can use our distributive property. 6 times x would be 6x minus 6. And then we'd have 4x plus 12, because we'd go on and distribute. Then we just need to get x by itself. So we can add 6 to both sides of the equation, which gives us 6x is equal to 4x plus 18. Then we can subtract 4x from both sides, which will tell us that 2x is equal to. Divide both sides by 2, which tells us x is equal to 9. Any questions on this here? Are we good with this one here? Yes? So the two parts of the chords multiplied together are equal to each other. We're not going to have one as complex as 49 on the test, but if you do have questions on it, I can address those individually. Questions on 50 or 51? I'll just do 50. For this here, when we have two secant lines, two secant segments, the exterior times the whole length is equal to the exterior times the whole length. For two secant segments, the exterior, so 7 times the whole length, so we have to add 7 and what's inside together, is equal to the exterior 8 times the whole length, so 8 plus what's inside. I would add first, because 7 plus 1 would give us 8. Negative 3 plus 8 would give us plus 5. I want to combine like terms because it is less to multiply, and we're going to have to combine them anyways. So might as well do it first. And now we can use the distributive property. 7 times x is 7x plus 7 times 8 is 56. 8 times x is 8x, and 8 times 5 is 40. At this point here, we would subtract 7x from both sides, leaving us with 56 is equal to x plus 40. And at this point here, we can subtract 40 from both sides, telling us that x is equal to 16. X is equal to 16. Any questions on any of this here? Are we good with this one here? Okay. 54. So with this here, we have a tangent segment and a secant segment. The tangent segment squared is equal to the exterior of the secant times the whole thing. So our tangent segment for this here is the square root of 1500. So we're going to have the square root of 1500 squared is equal to, well, the exterior segment is 24. times the whole thing, which would be 2x minus 6 plus 24. Would be 1500, yes. Because the square root and square would simplify. Because the square root and square will simplify out. They will cancel out. Now on the other side, we can combine negative 6 and 24 to get 18. Now at this point here, we can use the distributive property. 2 times 24 would be 48x plus 24 times 18 is 432. Now at this point here, we can subtract 432 from both sides. 8, carry the 1, 6, carry the 1. And I believe we should get 1068. And last but not least, we're going to divide both sides by 48, which tells us x is equal to 22.25. Any questions on this here? Are we good with this here? And that brings us to circles. Circles. Now again, the equation of a circle is y minus, well, we're going to normally start with x. X minus h squared plus y minus k squared is equal to r squared, where h and k are the center of the circle and r is the radius. So when we look at this first one here, well, the circle is centered at 0, 0. So our h and k would be 0, which really just leaves us with x squared minus plus y squared. And I can just count out to get the radius, which is 3, and 3 squared would be 9. So if we look at 57, one of the things we need is the center, because we can see that the center of the circle is not at the origin 0, 0. But if we look, it's at negative 6, 6. So that would be the center of the circle. So we'd have x minus 6, which would be x plus 6 squared, plus y minus 6 squared is equal to the radius squared. Well, we can find the radius from counting over. 1, 2, 3, 4. So this here would be 4 squared, which is 16. So this here would be the equation of the circle. For 58 and 59, find the center and the radius. So again, we're going off of x minus h squared plus y minus k squared is equal to r squared. So for 59, so we'd get the 3 and negative 4. But again, the sign should be opposite. Come on in. Okay. You're welcome. Now r squared matches up with 100. So to find the radius, we do need to take the square root of 100, which would be 10. So our center would be negative 3, 4, and the radius would be 10. So lastly, write the equation of the circle given the information. So here, minus h squared plus y minus k squared equals r squared. So we'd have x minus negative 4 squared plus y minus 2 squared is equal to the square root of 3 squared. So this would give us x plus 4 squared plus y minus 2 squared is equal to 3. So on these here, we just need to plug the numbers in and simplify where needed. So this here is the last one that we're going to look at with the point on the circle. Now looking at this here, really, with our formula, x minus h squared plus y minus k squared is equal to r squared. Well, they give us the h and k values, but they don't give us the value of r. Now to find the value of r, we can use the distance formula, which will be the square root. So we take the x values, so 2 minus 4 squared, plus the y values, 7 minus 12 squared, and we can plug this into the calculator, or we can do it by hand. And if we do it by hand, 2 minus 4 is going to be negative 2. 7 minus 12 is going to be negative 5. Well, negative 2 squared is going to be 4. Negative 5 squared is 25. So we get the square root of 29. Now, the square root of 29 does not simplify, but that's fine. We can leave it as that there, because once we simplify the equation, because x minus 2 squared is simplified as it gets, y minus 7 squared is as simplified as it gets. And the square root of 29 squared would be 29. So this right here would be our equation, and that's all that we would need to do for this here. Now, I will go back and look at the other question that we did skip. These here. Now, these here will be a bonus type problem, because really what we're wanting to find is this here, Fi or Ia, that would be the radius. Now we know that AC and FD are congruent, and if we cut it in half, that gives us 12. So the triangle that we're really trying to find with our radius, one of the side lengths is 12. Now, you're good. For the other side lengths, we know that 4x plus 47 is going to equal 7x minus 58, and we can solve for the value of x. Now, the first thing that we can do is that we can add 58 to both sides, which will tell us that 7x on one side and 4x plus 5, carry the 1, 105. Now at this point here, we can subtract 4x from both sides, and we subtract 4x from both sides, we get that 3x is equal to 105. Divide both sides by 3, and we see that x is equal to 35, which is nice and all, but we do still have to plug it back in. So 7 times 35 minus 58. 7 times 35 is 5, carry the 3, so it'd be about 105. Times 35 would be 245. Minus 58 is 187. So the last thing we need to do to find the radius is to plug these numbers in. So r squared is equal to 12 squared plus 187 squared. And we can plug that into a calculator. And then square root both sides and see that the value of r is about 187.38. Now that's a little weird, but that's about what we need to do in the process that we need to do to solve this here. So if you have any other questions, please let me know. Your test is to